Folks, hello, and welcome to midweek bonus for week number 4. What I've got teed up for this midweek bonus is problem 911. This is not algorithmic, so when you go in to look at your homework, this should be straight up as you see it here with the numbers that I have for this problem. So let's get into this, and this one I think is fairly straightforward. Edwards Manufacturing Company purchases 2 component parts from 3 different suppliers. The suppliers have limited capacity and no one supplier can meet all the company's needs. In addition, the suppliers charge different prices for the components. Component price data in price per unit are as follows. So in this table, down the left-hand column here, you have component 1 and component 2. And then across the top in these in the columns, you have the prices for supplier 1, supplier 2, and supplier 3. It says each supplier has limited capacity in terms of the total number of components it can supply. However, as long as Edwards provides sufficient advance orders, each supplier can devote its capacity to component 1, component 2, or any combination of the 2 components, if the total number of units ordered is within its capacity. Supplier capacities are as follows. So supplier 1 can supply 600 components, supplier 2, 1,000 components, supplier 3, 800 components. Finally, it says if Edwards' production plan for the next period includes 1,000 units of component 1 and 800 units of component 2, what purchases do you recommend? That is, how many units of each component should be ordered from each supplier? So what I have done is I have defined my decision variables across the top here. C1, S1 means how many units am I purchasing, or how many unit 1 components am I purchasing from supplier 1? C1, S2, how many units, or how many components of, or how many component 1 products from supplier 2, and so on and so forth. Just for the heck of it, C2, S3, how many components or how many type 2 components are purchased from supplier 3, so on and so forth. Then I have included right below there from this table the prices per unit, which become the coefficients of your objective function. And then in cell C7, of course, I have the sum product of B5 through G5 times the same cells in row 6. So B6 through G6. That is the objective function. Now, from a, from a constraint standpoint, the first 3 constraints I have here are the supplier constraints. So supplier 1 can only produce 600 units, supplier 2 can only produce 1,000 units, and supplier 3 can only produce 800 units. If you look in the body of the matrix here, notice here, I have a 1 here. So the number of units from supplier 1, and then also here, number of units from supplier 1. So this is component 1 from supplier 1, and this is component 2 from supplier 1. Second row here, number of components from supplier 2, type 1 components from supplier 2, plus number of component 2s from supplier 2. Same thing for 3. So these first rows, or these first 3 rows, line up with the suppliers. And then notice there is the final constraint here is that the next period, we need 1,000 component 1s. So the component 1s are in these these first 3 decision variables from the 3 different suppliers. So 1, 1, 1, which is just picking up all of those variables. The total number there must be equal to 1,000. And then for component 2, which is these last 3 decision variables, the sum of all these components must be equal to 800. And so if you go over here into Solver, let me start this. I'll just reset all of this. No big deal here. So first of all, make sure we know that we want to minimize the objective function, which is in cell C7. The decision variables will be B5 through G5. And then I think I can get this in two constraints. These are all less than or equal to. So we will add a constraint here that says all of these computed values. I will go back and make sure I am clear on how those cells are computed. Those must be less than or equal to the respective right-hand side values, 600, 1,000, and 800 respectively. So we will add that. And then we will add, we've got two equalities. So the computed values here must be equal to the computed values here. And let me just hit OK, and I'll close that and I'll come back to it. Let me just remind you, what we're computing here are the total number of units from supplier 1. So that's going to be the sum product of the decision variables times the values in this row. And again, since they're all 1, effectively what we're picking up is C1 S1 plus C2 S2, which again represents the total number of units from supplier 1. So that's how these first 3 constraints are going to work. And then finally down here, the computed values, again, since this is the sum product of this row times the decision variables, what we're picking up in this cell right here is C1 S1 plus C2 S2 plus, C1 S1 plus C1 S2 plus C1 S3, which is the total number of component 1 that is procured, and that has to be equal to 1,000. So if we go ahead and let's see, I don't think anything changed. Let's see if we can solve this, and let's see what we get. Let's see. It looks like we have purchased component 1 from suppliers 1 and 2. 600 and 400 is 1,000, so that looks good. And then let's see, it looks like we purchased or procured 800 component 2s from supplier 3. And then if we just look down at the constraints to make sure everything's good here, let's see, I used all the capacity from supplier 1. I didn't get all the capacity. I used 400 components from supplier 2, and it looks like I used all the components from supplier 3. Why might that be the case? Let's see, supplier 2. Let's see, a little more expensive than supplier 1, $1 short from supplier 3 on component 1. But one thing we will notice here, clear distinction on component 2, $1 less for both supplier 1 and supplier 3 on component 2. So we would certainly expect to see maybe a little less from supplier 2 in that regard. So again, I think everything certainly checks out mathematically just by looking at it. And then if we go and do a quick logic check, I think that checks out as well. Also, remember, let's see, we got 1,000 component 1s, and that constraint is met on the nose. And then we've got 800 component 2s, which is satisfied right here. So I think we're in good shape there as well. So again, I think this one's fairly straightforward, but again, just to kind of reemphasize some of the logic that we're putting into these, I hope this is helpful. And let's see, I think everybody's probably, if you haven't gotten into that midterm exam yet, let me just remind you to please take the practice exam. I'm not here to say that what you're going to see on that is exactly the same problem as you're going to see on your test, but it will certainly give you a good idea of the types of problems and the types of questions that you will get asked on that test. So make sure that you get a chance to go through that. If there's any questions, let me know. I hope this is helpful, and please enjoy the rest of your week. Take care.